A very good morning to each one of you. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for this fifth series in the webinar on Industry 4.0, jointly organized with Maxbyte. Thanks to the team from Maxbyte for accepting our request to host the webinar series. As you're all aware, the series is organized under the aegis of Industry 4.0 Expert Committee, chaired by Mr. A.N. Chandramouli and co-chaired by Mr. Jagannath from M2 Next. Mr. Chandramouli is the past president of BCIC. And I'm Rupa, Assistant Secretary General at BCIC, and I'm accompanied by our Secretary General, Colonel Harish, in the webinar. I'd like to introduce today's speaker, Mr. Surendran, who is the Chief Commercial Officer at Maxbyte Technologies. Thank you, Mr. Surendran, for addressing at the webinar today. Mr. Surendran comes with significant expertise in design, automation, knowledge-based engineering, with over 2 years of experience in industrial IoT. His primary focus includes developing IoT SaaS products, machine learning, and augmented and virtual reality to drive industrial digital transformation. His work in developing cutting-edge technologies is crucial for enhancing industrial operations, efficiency, and connectivity. Thanks to Surendran, and the Chamber also acknowledges the support of our annual sponsors who have been supporting all the activities of the Chamber throughout the year. I now request Mr. Surendran to take it over from here, and I would like to specially thank two of our member companies who are streaming this webinar in their conference room for the benefit of the large number of members instead of each one logging in. And thanks to our companies for their support in this initiative. Over to you, Mr. Surendran.
So hope my screen is visible.
Yes.
It's visible.
So good morning all. So welcome you all for the webinar series on smart and sustainable manufacturing solutions. I think over the past few weeks, we have been seeing various technologies on this industry 4.0 and how this is going to help the digital transformation journey for any industries. So in continuation on as a part of that particular series, today we are going to discuss or primarily focus on this autonomous mobile robots or autonomous industrial vehicles. So where this automation is key integral part of this digital transformation solution portfolio. So maybe in today's agenda, we will quickly touch upon what is industry, autonomous vehicles, what is autonomous mobile robots, how which is being useful for the industries, and what are the key benefits and ROI for that particular autonomous vehicles inside the industries. Yeah. So we'll start with this introduction of autonomous mobile robots, as many of us would have heard this term AMRs or autonomous vehicles or AGVs, robots, cobots. So these are some of the key technology that has been used like kind of many years before itself by the manufacturers for their automation purposes. So how this is currently linked with this digital and IoT is something very key for this today's scenario. So as we can see here, robots, cobots or production robots have been in place for more than 30 years or more before that itself, where primary big companies have already been deployed that robots and cobots for their automation, assembly line automation or testing automation or packing automation in various areas that has already been deployed. But still, we feel there are a lot of more opportunities for robotization in the industries connected to this industrial IoT and the digital transformation solution portfolio. So in line with or in parallel with the digital solutions, so how this automation solution also will help us help the industries to form a closed loop system so that they can have a complete 360-degree feedback of their shop floor or of their production unit or the packaging unit or the logistics. So whatever it is required for the complete end-to-end production operations for the on the day-to-day basis. So considering that as a company, we are also working on multiple opportunities, multiple areas where this can be strongly integrated with their digital roadmap for any industries also. So manufacturers still look a lot of area where they can transform their way into autonomous factories. So like digital factory, now people or manufacturers are keen towards the next wave of technology, or we can say next wave of technological transformation. They call it as light source factory or dark factory, where they wanted to run the factory 24/7, even without any human intervention. So that is called as a light source factory or the dark factory, we can term it as. So that is the like kind of an aim or the next vision for all the manufacturers with which they wanted to move their organization or their shop floor. As the first part of it is the digital, where all our machines connectivity has been made, all our data has been continuously monitored, and insights has been derived from that data. And the next step of that particular digital transformation is how this automation also can be a part of that particular digital transformation, like loading and unloading of the machines, like transportation of the goods within the factory and outside the factory, both intra-logistics and inter-logistics. And then processing of the work pieces, autonomous picking and packing, in the quality inspection, autonomous quality inspections. So and the installations and so on the various areas in terms of logistics, production, and quality. So how these automation can be integral part is something like the manufacturers started looking into. So this is like kind of the autonomous mobile robot market, how it has been significantly grown over the past year. So market size is around 5.6 billion estimated in 2024, which is significantly going to rise in next 5 years to about 10.9 billion globally. So similarly, there are a lot of opportunities that has been identified. Either it can be in the terms of sorting or pick and place or tugging or warehouse, for other production or material movements also. There are a lot of application areas that has been primarily identified by the manufacturers, so that where this AMRs or autonomous mobile robots or autonomous vehicles can be deployed. So what are the key drivers for this AMRs is something also very, very crucial. So based on what we can able to select this particular AMR. So maybe based on the speed, there should not be any latency whenever the material is required on the assembly line or in the production line. It should be readily available without any notification. There should not be any dependence on the manual dependency for the material movements. And as well as on the labor dependencies, and also on the modernization, as well as on the cost. How can we able to reduce the cost, as well as the safety is one of the critical aspects that has been brought into picture. So how safely we can able to move the material from one place to another place, how quickly we can able to move it, and how this can be integrated with our day-to-day production scheduling or production activity is some of the key drivers for this AMR. So these are some of the numbers shows that one. So the number of robots deployed in warehouse manufacturing will rise almost up to 4 or 5 times more, where many of the manufacturing industries are looking to automate their complete warehouse. You may be either using ASRS system as well as using the AMRs for the material movements from the warehouse to the production, and then from the production to the quality, from quality to package, and packing to dispatch. So the complete material movements, how it can be automated is one of the key drivers that every industry is now looking upon. So every year Gartner will release this hype cycle where it will identify key technological areas for the next 5 to 10 years. So what are the key technologies that will drive the industry? So if you can see humanoid working robots, autonomous data collection and inspection, autonomous trucks, mobile sortation robots, warehouse picking robots, autonomous vehicles. So these are some of the key, what we can say, a key technology, or we can say a transformation tool for the next 5 to 10 years, where every industry is going to adopt it. And then they can start using, or they can start implementing in their day-to-day process as well. So this is something which has been released by Gartner over the past few years, and maybe similarly for each and every, for digital there is a separate hype cycle, for automation, autonomous AMRs there's a separate hype cycle. Similarly for all the technologies, they're releasing this hype cycle where we can able to find what are the key or what are the next wave or next gen solutions that can be used in our shop floor, in our manufacturing industry, so that we can able to completely adapt to this particular technological growth. So this is like kind of a, as I said, right, the dark factory or the lighthouse factory is like kind of a factory of the future, where we can able to automate the complete operation of the factory with help of robots, AMRs, and the digital solutions, so that the complete operations will takes place autonomously without any manual intervention. And then all the movements, material movements inside the factories, inspections inside the factories, and the data collection, the data gathering during the particular assembly process or the production process. So all this will be completely automated, all digitized, so that we can able to relay, or we can able to take the quick decisions on the data that we are going to get it, and how these robots and cobots or the AMRs react to this particular scenarios, the particular situations in the shop floor is something now manufacturers started looking into. So like kind of a, this is like kind of a more like kind of a factor, a future of the factory that we are visualizing it. So like digital maturity autonomous levels. So if you take in any digital maturity, there will be around 6 levels, where we start with computation connectivity, then we go for visibility, then transparency, then predictability, and then autonomous, so adaptability. So these 6 levels we are thinking in terms of digital. Similarly, for any factory to transform autonomously, again we have 6 levels of the 6 levels of maturity levels, we can say, like manual, semi-automated, automated, and then go for semi-autonomous and autonomous orchestration and autonomous operations. So we can able to find currently which level we are in, and also to move on to the next levels, what are the solutions that we can deploy, so that we can able to reach the highest maturity level for autonomous industries as well. So this is one such example or one such maturity framework from Roland Berger. So where we can able to assess the factory based on the automation alone, based on autonomous solutions, and also based on the degree of control intelligence that we are currently having over our process or over the machines. So we can correlate both of them, and we can able to arrive at a digital maturity level, and then we can able to do the gap analysis, and then we can move on to the next level of automation in the, or next maturity levels in the autonomous factory. So this is one such multiple maturity models available. So maybe we can use it whichever is suiting for our particular process and particular factory. So if you take the complete end-to-end value chain, there are multiple areas where we can able to use this automation solution, autonomous vehicles, right from the stores till the finished goods. So if you take the stores where we are going to do the warehousing, so we can use ASRS system, automated storage and retrieval system, and also the sequencing, how it can be completely automated. Then from there we can go to the machining and fabrication, where the automatic loading and unloading of the materials will happen, and then autonomous material movement will be taking place with help of this AMRs, and then go for the assembly line. And then even in the inspection, how the quality process can be completely automated with the help of this autonomous quality inspection system. And then the finished goods area, where we can able to palletize it, and then move the materials from one place to another place with help of BOPT or trackers or tuggers, whatever vehicles that we are currently having, or forklifts. So through this complete process, we have this intralogistics where AMRs, autonomous BOPT, stackers and truckers or trolleys, autonomous trolleys will help us in this material movement. And if you can see the underlying the complete, it will run on this industrial IoT system, where the machine-to-machine connectivity is already being established, and the real-time closed-loop feedback for the autonomous operations is already being established in the particular system, so that we can able to deploy, or we can able to move on to this autonomous factories. So there are multiple factors that will determine the levels of autonomy for autonomous mobile robots. So whether you want only a navigation system that will help us to navigate from one place to another, or we can able to have the material handling, where the materials can be autonomously moved from one place to another place. and then how this can be integrated with the other facilities in the system, how this can be integrated, or the ability of the machines to communicate with the machines, and then without any manual intervention, how the complete process can be automated. So this is like various levels we can able to decide for our operations what kind of autonomy level that we require, and then based on it we can able to either go for this robots or cobot automation, and then go for this AMRs, and then go for autonomous vehicles for the complete automation of the system. So there is a strong difference between AGVs and AMRs that we can already multiple questions will come whether we should go for AGVs or whether we should go for AMRs. So this slide maybe give a clear idea on what kind of platforms are available, and to what application we can use or what kind of automation solution. So if you can see, there are mobile platforms that is available. If you can industrial application, there are if you go for in a mobile platform, then we can go for either navigation type or a manipulator type. So manipulator primarily deals with in the industrial robots and cobots and other areas. So we directly call it as industrial mobile robot that can be integrated with our system. If you go for navigation type, then there comes the AMRs and AGVs. So AGV is nothing but it's an automated guided vehicle where the vehicle will be moving in the shop floor based on some guidance. Either it will be like kind of a QR code on the floor, or it can be a magnetic strip on the floor. So based on that particular guidance, the vehicle will be moving in a straight line along with that particular on that particular line itself, which has been laid through the factory. So that is called the guided path vehicle or autonomous automatic guided vehicle. The other side is like autonomous mobile robots, where there won't be any guidance that will be available for the vehicles to move in. It will be completely based on the either the lidar or the some other autonomous technology that has been mounted on the particular vehicle. It will automatically try to map the complete shop floor. It will automatically find the shortest route available or the best path available, and then it will start navigating on its own. So that's the key difference between autonomous mobile robots and automated guided vehicles. Again, here based upon the application that we are currently using, or currently our factory is running, or the process that we are being getting followed, we can either go for AGVs or AMRs. The only maybe disadvantages in AGVs might be there might be frequent relaying of that particular magnetic strip or the QR codes, because it might get tampered, or it might get damaged over during the course of the usage. Maybe every 6 months or 5 months we need to replace that one, but that kind of disadvantage not in autonomous mobile robots, where it is able to find its path without any navigation. But on the cost side, AGV is little bit on the lesser cost, but AMRs comes with on the higher cost side due to this technological adoption. So this is the primary, we can say, the classification of industrial robots that we can say that can be used with help of either on the navigation type or on the manipulator type, that we are based on the applications we can able to select what kind of autonomous solutions that we want to have it in our process. So this is like the key difference between AMRs and AGVs. So AMR primarily deals with trackless navigation. It can go around the obstacles. It can be easily remapped with any for any factory. So it's not only like once it is can be used for one location, it cannot be moved to the other location. It can easily be remapped. So it requires only a charging station. So where it can able to just go and charges it, and it can deliver to the user location. It can travel around the people and obstacle, and easy to expand and change based upon the process that we are currently using it. Whereas on the AGVs, it requires tracks. So whenever there's obstacle, because since it is following one particular path, it cannot take or go around the obstacle, to stop until the obstacle is cleared. And once we want to use this to some other location, again, we need to shift that, or we need to relay that complete tracking so that for the AGV to follow it. And then it will be on the path. It does not deliver to the user location. Maybe it will be on the path of that particular tracks that we are laying it. So it travels in dedicated paths and difficult to expand. So this is some of the advantages that AMR is having over the conventional AGVs. So now most of the industries are now looking to move or adapt to this particular AMR technology so that they can able to expand and easily use it for their various or the various process areas, like either it can be warehouse. It's AMRs can be configured in warehouse. Maybe the next state can be reconfigured in the assembly area, or the next state can be reconfigured in the packaging area, and it can be used for various purposes as well. So this is advantage that AMR brings in over the conventional AGVs that has been used in the industries. So again, based upon the form factors, there are multiple forms that AMRs can be available, and also based on the loads that is being carried. Also, the AMRs can be on different forms. For example, the trucks is one of the form of a AMRs where it can able to pull the load. It is kind of for a kind of a heavy load, like more than 1 ton or 2 ton. If there's a load, then we go for this truck. Or if it is like kind of an 50 kg to like kind of a 600 to 700 kgs of weight, then we can go for a mouse type AMRs where we can able to have a platform, and then it can be able to lift the material, or it can able to tug that material, tug that material also. So forklift is another kind of AMR where it can be used to lift the loads, and it can be able to relocate the loads from one place to another place. So based upon the application, based upon the loads, and also based upon the driveway capacity and the usage, the AMRs can be on different forms. And the existing vehicles also can be converted to AMRs. Say, for example, our existing BOPTs, if you are having any battery operated pallet truck vehicles, so that can be converted into an AMR. Legacy cleaning machines can be converted to AMR so that it can operate without any manual intervention. So likewise, any vehicles also can be converted into autonomous vehicles, and AMRs is as a separate platform is also available. So as I said, there are two variations to this AMRs. Either it can be a platform-based approach where if you see a picture, there will be a base platform, and top of it can be used for multiple applications. Whereas the other is kind of this vehicles can be converted to AMRs like forklift, stackers, tuggers, or BOPTs can be converted to AMRs, and that can be used to pull the loads or move the loads from one place to another place. So these are the primary variations or primary application of this AMR. So as I said, there's multiple of significant applications. Either it can be used as a conveyor, like kind of a replaceable conveyor inside an assembly line, a double conveyor, where pallet transport, lifting can be done, or tugging can be done. So again, based upon the usage and application, the AMRs can be reconfigured to any of these particular type, and it can be used in our application. And multiple areas like or multiple domains, industrial, logistics, warehouse, e-commerce, defense application, healthcare applications. So there are multiple areas where this AMRs finds a significant usage. And these are again some of the examples, like in healthcare. How it is helping the people, or how it helps in the movement of the goods, not only the material, even the administrative materials like office files or patient history files or something like that, meals, clothes. So that can be used to movement of these particular any kind of movements that can be automated or made it autonomous using this AMRs. In the manufacturing, primarily used for this raw material movement or the finished good movements or the quality inspection. In the hospitality, where it can able to serve the guests, or it can be able to guide them as well in the retail as well as in the warehousing. So the multiple applications, significant applications where the AMRs is now finding its space. So these are the major components and features of an AMR. So like there are multiple on the vehicle. It can be either a lidar-based navigation system, and there can be a significant safety control system that can be embedded to the particular vehicle, and the load carrying mechanism and drive mechanism can be completely customized for the movement. And we can call the intelligent controller of the AMRs can be embedded there. There can be cameras kept to so that to identify like kind of obstacles or any depths or any potholes on the way, and the safety sensors, right? So that can be easily fitted so that all the 360-degree obstacle reductions can easily be customized or easily be configured in any particular vehicle. So these are the key technological concepts, and the major these things like wallet of things, fleet management system where multiple AMRs can be controlled in one single application. And the remote monitoring of this particular system is available, and the battery management system is also there, and the device control system where we can able to control the complete operations of this AMRs is also now available. So these are the primary components and the features of any AMR that can be configured or that can be built from the scratch as well. So how this AMRs is used in this one of the significant application is on the Kanban, where it can be used for the industrial intralogistics. So where the materials will be continuously moving between one machining area and then it will go for the assembly area. So earlier they were using paper-based Kanban system. So where it's a normal Kanban system where high manpower cost, delayed data, and the loss of wrongly processed cards, insufficient size inventory, longer lead time are some of the basic disadvantages. So now industries are shifting towards e-Kanban, where they have the real-time visibility of this particular products, and they can able to manage the inventory in a quite optimistic way, and the lead time is much shorter. So this AMRs is now being an integral part of this one. So how that AMR and IoT-based Kanban system is now all the industries are adapting. So where this movement of these particular trolleys or particular materials from one station to another station is complete autonomous. So based on the cycle time, so once the machines are connected, right, so a particular operation, and we can have the live the data of this particular performance of those machines. So once the product is completed or machining operations completed, the signal will be automatically given to the AMR. The AMR will go and pick up this particular material and will deliver to the next station. So likewise, the complete material movement on any particular cell or a bay can easily be automated and digitized, so that there is no manual intervention required. And whenever there is an whenever there is something that has to be notified to the users also, the system is able to notify either to email or SMS alerts. So whenever the vehicle is not moving or whenever the production is not happening, email and SMS alerts will be notified to the users. And also the same for the vehicles also will be completely monitored. So whenever the vehicle is moving or not moving, whether it is moving with load or without load, at what speed the vehicle is moving. So the complete monitoring of this vehicle is also available for the users, so that they can easily monitor the performance of this particular line or bay or the department, so that we can able to optimize or improve the performance of this particular bay. So AMR has significant industrial applications as well. So one such application is material movement in the machine shop, where the machine-to-machine component movements can easily be automated with help of this AMRs, either in the form of a pallet or it can be help of a cobot-based material picking and movement, where a cobot or robot will pick up the material from the machine and it will place on the AMR and then it will start moving it. Or it can be placed on a pallet and the pallet will be either lifted or it will be tugged over the stove to the next machine. So maybe it will be mostly like kind of a fixed part movements from one machine to another machine. Similarly, in the assembly lines as well, where the movement of semi-finished component or semi-finished component in assembly line, within the assembly line, or from the assembly line to the testing area or the finished goods areas also can be automated. And then this continuous movements of the materials from one area to another area, either from a subcell, there'll be multiple sub-assemblies over the main assembly lines. So once the sub-assembly line operation is completed, again the material from the sub-assembly to the main assembly can easily be transferred using help of this AMR. So either it can be a fixed path or it can be an like kind of an on the go path direction as well, based upon the assembly operation or assembly process. And again, from the finished goods for the other material movements across various departments, whether it can be from the warehouse to the production area, from the production to assembly, assembly to the quality inspection, from the quality inspection to the packing area, from the packing to the dispatch area. So wherever there is a huge material movement is involved, so all these material movements can easily be automated with the help of this autonomous mobile robots or this autonomous vehicles that comes into that is already being available inside the factory. So what are the key benefits for AMRs? So again, one of the primary reason why everybody is thinking to adapt to this AMR is mainly on the overall efficiency and the speed. So how this can be easily be addressed is addresses something all the manufacturers looking into, and one of the primary solution that they are having in the hand also is the AMR. So again, material handling can account for 30 to 75% of production cost and increase the operational cost by 15 to 30%. So this is one of the key area or untapped area that every industry is now looking into. So how this can be automated or optimized is that can help in the cost reduction area, something that the industries are looking into tap on. So again, it removes at least 15% of operational cost. One of the major areas is the safety. So where dealing with the heavy material, or they will dealing with an like kind of an what to say, unsafe materials, right? So wherever that kind of an situation is there, this AMRs can come in handy. So it is flexible. It can be easily configured across multiple areas and multiple stations or multiple departments. It is dependable, so it's easy to install, and it also is scalable. So it is built for the future, so it can be scaled to other areas as well. So this is something like kind of a normal conventional systems, right? So when you think thought of automation or think of automation in terms of for the material movements, there are multiple uh, methods or concepts available. One is conveyors or machine operators, AGVs and AMRs. So this slide shows a key difference or key advantages and disadvantages between the various concepts here. So if you can see, the primary advantage of this one is there is no operators, no physical barriers, and this maximum routing flexibility is available. So that where it can go for even like kind of intrinsic automation, or like kind of a very process-driven areas also. This can be implemented. This can be easily automated. But on the other side, the disadvantages of AMR is like kind of it requires large capital investment. That is like kind of one of the major area that all industries are looking upon, because cost is on a little bit higher side, and also based upon the loads, again the cost will vary accordingly. So limited experience with technology requires docking station. So there will be a separate docking station should be available for this one, and the trace or other intermediate transport platform to facilitate transfer to the next mission. So there's it is easy, or it is beneficial when we have a dedicated line or dedicated path for this material movements or for this AMRs, so that it can easily come and easily can commute in that particular path. If you're having where there are a lot of human interventions are there, then again the AMRs will usage of AMRs will be again a question mark, like because it has to go around the obstacles. It has to see on the efficiency and the performance side as well. So again, on the advantage side there are many, but again on the disadvantage side also it has to be looked upon, so that we can able to select different AMRs based upon our operations. So how to get started with an AMR? So know your requirements, collect information about the environmental use cases. So we can say do a quick analysis of how it will save the time, and also avoid perpetual pilot mode on development side. So maybe again, or not all the these things will can be automated. Start small and then go for the bigger automation or a bigger picture. So to start with, don't immediately start with a complete end-to-end material movement automation. So maybe go for a department-wise or go for a module-wise based automation, and then go for a complete set of automation. So again, based upon the load, based upon the environment, and based upon the users and the bottom benefit we are getting, we can able to select our AMRs and select our particular autonomous vehicles for our particular operations. So with this, I will quickly show a couple of areas where we have deployed this AMR. So maybe a couple of videos that will help us to understand the different AMRs usage. So as I said, there are two areas. One is the autonomous vehicles, where any industrial vehicles can be converted to autonomous vehicles. And the next one is the platform-based approach, where a base platform will be available and it can be used for multiple applications. So again, it comes with industrial IoTs, AI and ML-based AI ML-based system, robust navigation system, battery management system, fleet management system, and various sensor and controls for the safety. So this is like kind of a platform-based approach where we have a load capacity of up to 500 kg, and then we can have up to running time of 8 hours and maximum speed of up to 2 meters per second. So this is like kind of a recommended speed for any AMRs, like maximum 2 meters per second only they are recommending based upon the ISO and ANSI standards, and then comply with all the international safety standards. So based upon the, again, application, it can be used as tugger, it can be used as a lifter, it can be used as a roll conveyor as well, or it can be used for any other healthcare applications also. So this is a primary architecture. So how AMRs can be configured. So there can be multiple AMRs inside the factories, and we can able to connect all these AMRs into one single system, and we can able to control those particular AMRs as well. And this is like kind of how this AMRs can be configured with the help of the root node systems and also the fleet management system. How different, so they have a separate ROS processors for each and every AMS, so how that can be combined together into one single system also, it can be configured. So this is like kind of a basic, like kind of architecture, we can say, for configuring our AMRs. So this is one such example of an AMR, so where it can be able to lift a small vehicle, so for a small capacity of up to 320 pounds, or we can say 350 pounds. So this is one such application of one of the AMRs. So as I said, right, there are multiple use cases where an industrial vehicle can be converted autonomous vehicle, and one such example is this BOPT. So how this BOPT can be totally converted to autonomous vehicle is something we have done for some of our customers. So maybe this this video will show you an example of that one. So where we got an so this is BOPT got from Godrej. It's about 2-ton capacity. So this vehicle has been converted to autonomous vehicle. So it comes with an HMI as well, so where users can configure the start location, end location, so between which station it can be moved upon, right? So based on that particular location or the selection, the autonomous vehicle will be moving. So all the operations, the lifting operations, the placing operation, everything is automated here, or were made autonomous in this particular vehicle. And as I said, all the 360-degree safety reduction or safety mechanism can be inbuilt into this particular vehicle. The speed can be also controlled. So based upon the environment, we can either control or we configure the speed up to from 0.5 to 2 meters per second as well. So the emergency stop button, so the vehicle can be stopped at any moment of time, and it can be moved to a safer place also. So it has reverse motion safety sensors also. So it identify the people or obstacle at the reverse side, and it will able to identify the pallet with help of the QR code. It can able to identify it, and it can be used for identification as well as it can be used for alignment as well. So this will be aligned with the in center of the particular pallet, and the pallet will be lifted and it will be delivered to the required station. So this is one such example of how an existing vehicle can be converted into an AMR. And again, it can be either configured in two ways. So based upon our production scheduling, this vehicle can automatically come to a particular station based upon the particular machine's runtime and the part finishing time, or else each station or each line will be equipped with a push button. So whenever operator wants this vehicle, they can just push the push button and this vehicle will be coming autonomously to that particular station. So there are multiple ways this AMRs can be configured for the material movements. And that is like, and for a bigger vehicle, a bigger load, and if the loads are very small, we can also use these trolleys into autonomous vehicles. So where we can configure multiple stations, and these trolleys can be used to move materials of weight from either 5 kg to 150 kgs. This will be helpful majorly where the tools movement as well. So from the tool room, various tools can be given to the machining area autonomously, and also where the inspections has to be done in the operation in the shop floor area, right? So where people will go and pick up on the particular material, sample material, and every time they will be moving between the stations and the inspection area and the assembly area. So those kind of movements and those kind of process can easily be automated with the help of this particular AMRs. So again, this is completely configurable by the users, so they can just take the vehicle, configure for their shop floor, and identify the stations where it has to stop in between. So everything can easily be done by the users, and then they can able to start using this vehicle. Maybe it might take maximum 2 to 3 hours time for configuration, and then they can start using this vehicle for their day-to-day operations. So again, here also all the required safety aspects has been inbuilt. The vehicles can be it can either stop on the obstacle detection or it can take an alternate path based upon the requirement, and then we can able to configure it accordingly as well. So this is another application. And one more application that we saw is on the cleanings area, where on the facilities side, where we can see the cleaning machines like this, right? So how that can be converted autonomous vehicles. So this is one such example of converting an walk behind cleaning machine into autonomous vehicle. So just define the zones where it has to be cleaned. So based on that particular time, the vehicle will automatically go and clean that particular zone, and it will come back to the home position. Again, it has all the intelligence embedded in it, the fresh water level, dirty water level, battery level, everything can be monitored, and all the required notification alerts will be sent to the respective teams based upon the configurations also here. And we can also analyze the cleaning performance also. So what is the performance of the cleaning that has been done? So that also will be available as a report for the users to take it from this particular machine. So the end of that zone completion, we do a final round at the borders so that if any areas has missed up, right, that can be easily be cleaned here. So again, this is one such example of this particular AMRs. So this is like not an AMR, but again, it's another application that can be seen here, how this can be particularly used, converting an existing trolley into a motorized trolley, so that users can easily use it for navigation purpose. So this is one use case that has been done for e-commerce, bigger e-commerce company. So where the woman workers, they wanted to move this trolley, which is pretty much heavy. They can carry up to 400 kgs. So they're finding it difficult to push or pull it. So they converted that into an motorized trolley. So just like kind of operating a vehicle, these trolleys can be operated. But again, this requires a manual intervention here, just for pulling and this thing. This is another one such of another example of a small automation here. So one more use case where robots and cobots can easily be used as an integral part of the automation system. So this is one example of an torque checking system where torque of each nuts and bolts to be checked for their particular torque value. So the cobot will take a bolt and it will place it in the fixture. The torque checking system will come and check it. And after the checking, it will give the feedback either pass or fail to the cobot. And the cobot will put in the pass bin or the fail bin accordingly based upon the torque value. So like any kind of this special purpose automation systems can be inbuilt using these cobots and robots. This is one such example of an station automation, or we can say an line automation, where cobots has been deployed to automatically pick and place the material from one machine to another machine. This is a complete process automated. There is no manual intervention required here. So once the machining is completed, the machine will communicate to this particular cobot. The cobot will again go and pick up that particular material, place it in the next machine, and once all the operations are completed, it will place in the finished goods area. So similarly, robots and cobots, how it can be used for assembly lines and assembly stations here. Multiple automation systems that has been can be easily deployed across the process lines here. And camera-based quality inspection is one of the biggest area that is having a huge impact. So how this quality inspection process can be automated, like presence of any object, orientation of any object, or like kind of an other quality checks, how it can easily be automated, or some of the areas that quality-based inspection is being taken upon. And the storage automation system, ASR system, so how it can be easily be has been integral part of this particular automation solution portfolio. So how the warehouse automation system can completely be automated, and it can be easily integrated with our existing SAP or ERP systems as well for their continuous production lines. And even drones are now finding a huge space in this areas. So where drones are used for this automated inventory management. So where every 60 minutes, a drone will automatically go and take the stocks, and it will data will be automatically transferred to a system rather than the person keep on checking the stocks. Right? So those processes can easily be automated with the help of the drones as well. Yeah, so based upon again the application and based upon the usage and also one of the primary criteria on the budget also, we can select what kind of automation system that we want to start with, and then we can slowly move ahead with our autonomous factory implementation. Yeah, so that is something which I want to share it for you with today. So any questions now we can discuss.
There is a request to all the participants. We have enabled the audio and video for you. Please go ahead and ask the queries.
46 people are there, no?
Good morning. My name is 𝙊𝙛𝙛𝙚𝙬𝙚. How does one do an estimate of the investment which is required? Especially, is it possible for MSMEs to think of such?
Yeah, as I
implementation?
said, right, one of the primary factor is on the cost aspect. So based upon our operational process and what kind of area that we are going to automate it, right? So we can decide what kind of automation solution that we want to have it. So we cannot, especially for MSMEs, it's better to go for like kind of a module-based approach, maybe select a smaller area, try to automate that one with help of cobots, or start with the conveyor-based systems, and then see how the step-by-step automations can be done, right, rather than going for a complete set of automation at the initial phase itself. So based upon the requirement, the application that we are trying to automate it, based upon the process that we are trying to automate, we can select a suitable automation solution. But again, cost is one of the primary factor or the major criteria. So that has to be that will be a challenge for MSMEs in this particular technology implementation. So that has to be worked out with them as well.
And are there any special designs for AMRs working in heat treatment areas?
Yes.
Any special
So,
design consideration?
yeah. Because based upon the particular application only, the AMRs will be or designed itself. The platforms, if that particular platform is suited for that particular area, then we can straight away use the existing one, or it can be redesigned to adapt to that particular process.
Thank you.
I have a question. This is
Yeah.
Srinivas.
Yes.
What kind of flooring is required for this? I mean, for this AMRs, is it a regular cement flooring or?
Yeah, it can work on epoxy. Major best suited flooring is epoxy flooring. So where most of the industries will be having inside the shop floor, inside their factory. But it can operate on the cement floors, but try to not in a very uneven surfaces. Only if it is not having a major like kind of uneven surface is not there, means then AMRs will be smooth to operate.
Okay. Can it go on inclined surfaces or?
Yeah, inclined is limited, maximum up to 3 to 5 degrees of inclination it can climb. Again, based upon the load. If it is heavy load, it can 3 to 5 degrees. If it is a small load, then it can go up to 8 degrees of inclination.
Okay. Thank you.
Yeah, thank
Hello.
Yeah.
Good morning. I am Sumar
Good morning.
Kalyan Ghosh from TVS Motor Hosur.
Yes, sir.
Regarding your product range, are you having any LMR like a latent mobile robot which is low height and which a lifting mechanism with a complete automated operation like a pick and drop and empty collection automatic?
Yeah. So based
with a
upon
natural navigation without
yeah.
any reflectors or QR code used in the soft floors?
Correct. Yeah, that's the primary advantage of AMRs. It doesn't require any reflectors or QR codes. It automatically find with help of the natural mapping or real-time mapping of the particular shop floor. So that is already there. And we have a complete lifting mechanism that is available for lifting the material. So cobots and robots will be deployed along with the AMR for the lifting and placing the materials on the AMR and then for movement. So those
No, I
kind of
don't. We are not looking of cobot robot integrated LMR or AMR. I want just like a 500 kg to 1 ton payload lifting mechanism, which height should be latent mobile. Height should be less than around 250 millimeter, because it should go below our trolley.
Correct.
Okay, not maximum 250 millimeter, because otherwise we have to, because thousands trolley have to modify.
Correct.
Okay, to increase the height. If you have that kind of product, we can have a separate session with TVS Motor.
Sure, sir. Maybe we can have a separate offline discussion on this one as well. So maybe we'll connect you offline, because we're having that one. We are having we call it as mini lifter and mega lifter. Both these things are available, and as I said, the size of the height will be minimum, so it can go under the trolleys as well. So that we can able to showcase to you.
Yeah, I have many queries, but I don't want to be discussed here. We can have a separate, dedicated separate session with the TVS Motor.
Sure.
Okay.
Okay.
Thank you.
What kind of navigation system you use? You say cameras are additional, which you can put cameras, but then how does your AMR sense any obstructions? Is there some kind of laser sensors or whatever inbuilt? How does that work?
So we primarily use LiDAR-based technology for the mapping. So either it can be a 2D LiDAR or 3D LiDAR based upon the environment. We can able to use it for the complete mapping. And those LiDARs also will be acting as an obstacle detection sensors. We have a separate ultrasonic sensors and proximity sensors deployed onto the vehicle. So that will be used as a safety sensors. But the LiDARs also will act as an separate safety sensors as well to detect the obstacles.
So are you saying that you actually map the initial layout into your system and
Yes.
with all the obstructions, but then if some things change, let's say a shelf is there somewhere and somebody moves it, how would that affect the functioning of your AMR?
Yeah. So that's what I said. It is like kind of a real-time mapping. So we will map the complete shop floor first for the path and everything. So the obstacle is like kind of real-time obstacle detection. So whenever it comes, right, the sensors or cameras will detect that obstacle and will try to find an alternate path, or else it will wait until obstacle is cleared.
Okay. Understood. Thanks.
Okay.
Then in dark, will it work if it is a LiDAR based thing? If there is no light, power outage, or
Sorry, your voice is breaking.
sir, if it is LiDAR means it is light sensing, no?
No, LiDAR is not basically on the light. It not only works on the light, it works on some on the object intensity based identification. So
But
light
what I'm
is some.
asking is, if there is a power outage in the second shift or third shift and there's no light, will it still work?
Yeah. It will
For
still
some time.
work.
For some time, not that it is light outage is going to be for hours together. Maybe 5 minutes or 10 minutes since till the time that this thing system gets restored. Will there be any danger or accidents?
No. So for that only, we majorly, if the vehicle in this some extreme conditions, if it is not able to find the path, it will not move at all, and it will start giving alarm buzzer for the user so that they can able to come and see whether what is stopping on that one or what is actually happening there. But if it's able to find the path with some minimum sources of light, and also we are having secondary system like 3D depth cameras as well, so that will help us to navigate inside some of the dark areas also. So not only depending full on the LiDAR, there are multiple other devices like 3D depth cameras also integrated with the system, so that they also come in handy for identification of the particular path. But in some extreme cases, the vehicle will not move at all.
Thank you.
One minute. If you have a 3D LiDAR based SLAM, okay, without referencing in shop floor, we don't want any QR code to be pasted in the floor.
Correct.
Or any reflectors in the wall.
Correct.
Okay, it can be straight route. We can navigate through the 3D SLAM. Okay, only the auto docking or pick up and drop area, we can use some reflector or QR code or trolley identification you can use. Okay, but balance area, you cannot use any QR code in the floor or any reflector in the any supportive wall or anything, because those are very, very dynamic. Okay, we cannot control in soft floor. Okay, with that kind of product, if you have, okay, we can work out 3D LiDAR based. I don't want 2D.
3D.
Okay. And with a low height compact with my peripheral modification, I want to minimize. Okay. Otherwise, if you go for standard your product, there is a heavy impact of our existing method of transportation. We have a trolleys of maybe 40,000 sub trolleys, and we can have a only 200 height. We need to special. I have to use some spacer for increase the height. Okay. But I cannot increase much height.
Sure.
Okay. And those are I have just given the brief up to you. You be ready, and then you can connect. So we'll have a next level of discussion.
Sure. We'll have a separate offline discussion on this one.
Okay.
Thank you.
Any need for increasing the space, because we are allowing the AMRs to avoid obstacles and deviate? Will the shop floor area need to be increase?
No, the AMRs will be designed for the existing shop floor size only. So based on the existing shop floor size, we will configure the safety distance path of the vehicles as well accordingly. So prime
Okay.
90-95% there will not be any need to modify the shop floor space based for the AMRs. We'll try to adapt to the existing space only.
Okay, thank you.
So what would be the power consumption of a small loading unloading machine for around 700 to 800 kgs?
Power consumption exactly, maybe I will check it out and I will come back to you, but it will not be much because it's like battery based, right? So for a complete charge of the battery, it will take around 4 to 5 hours of complete charging, and it can have the runtime of 8 hours of that one complete full cycle of charge. And we will have a 2 battery swapping methodology so that it can be continuously be running on that one. But to completely charge one battery, the power consumption what is required, that is the only thing. But the unit wise, I will maybe just check and get you back.
What would be like the power of the battery in itself?
It's a normal LiFe 12 or 24 volt mAh battery.
Okay, done. Thank you.
I think if there are no more queries, then thanks all for your time and for patience listening. And please do get back to us if any specific questions or for any specific clarification. We'll be more than happy to have a discussion with you as well.
Thank you very much, sir.
Thanks a lot.
Thank you.
Okay.
Thank you very much. Thank you.
Thanks, Mr. Surendran. That was quite a very insightful session. And if there are any further queries, we will definitely let you know. And I also request the participants to share in your feedback at the link provided in the chat box. Thanks to Maxbyte once again for this educational series. Thanks to all the participants for joining this session. Thank you.
Thank you.
Thank you.